Hello everyone! In this guide today I will show you how to set up a fully encrypted Linux system on a SSD and use a small part of these SSD for the cache of your HDD. So if you don't know, a cache is something on a faster device or faster storage unit to save often used files and from a slower device and give it to the CPU when needed. If you're wondering about the look, well, right now it's black, or something strange about this video, well, how it looks, but it doesn't look the same as yours, for example, two mice or something, it is because I use a virtual machine for it. I use the VM player and install their Linux because otherwise I don't know how to capture it for you. So now we are in install menu and started. This is we use Elementary OS. It's a very nice distribution. It comes as a pay what you want model, and well, you can get it for free, but it's really, really nice. So we just try Elementary because we need to do some stuff because we can actually before we can actually install Linux. As you can see, it has this look and feel of a Mac OS, but it is Linux, so it has everything nice from Linux, but also not the ugliness, but a very nice UI. When we start our trial, we can use the Windows key on our keyboard and T to open up the terminal. If you don't have a Windows key, well, I don't know why, then you can also go Applications and Terminal from here. In the terminal, we maximize it. We can use the command sudo I to go into root mode. Now we are ready to see what disk we have actually in our device. Oh, if you see, I use a lot of wrong keys. This is because I'm not familiar with the US keyboard layout. I have a different one, which makes it a little bit hard, but we come to it later. In this device we have a disk at SDA with 300 gigabytes, this is our HDD, and one at STB with 128 gigabytes, our SSD. It is similar to my laptop where I first used this. Yeah, for obvious reasons, to show you how I did it at the laptop, now in the virtual machine with virtual disks. Now, we don't want to forget where we have the essential mounting points, so we save them. We use the SSD saving point, and right there our SSD for SSD, and for our HDD we use our HDD point. Now for the next step, I explain my blog at ransom.net how to wipe your devices clean. You should wipe your devices if you have some previously installed sensitive data or you want to go for the maximum security because we want to encrypt our system. If you don't, well, I didn't do it now. I think when you have a good password, it should not be decrypted so easily, so it doesn't matter in my opinion. Now, we have now two devices, but we need partitions on our SSD. One for our boot, which is not encrypted at all because boot can't be encrypted, and two for our cache, and a bigger one for our system, or actually Linux distribution system where it will be installed. The cache is for the HDD, which is not a partition. We didn't need to partition it because we can use it fully. We use a graphical view for that. We don't use the terminal because I think it's nice in this way. Now we change to our SSD, and there you might want to create a partition table if you not already have one, and we use GPT for that. After you have a partition table, you can create a new partition. Now first for our boot, this is 1024. It's primary, ext4 is good, and we call it boot. Now we need another one with the size, let's say 30 gigs, 3720 is also primary. We call it cache because it will be for our cache, and we use XFS for it. Well, I'm not sure if the file system actually matters for our cache because it will maybe be overwritten later, but for now let's do it this way. And we need the last one, everything else, for our system. And we can also use XFS for it. And we are finished. Say everything's okay. Yes, yes, yes. Perfect. Now we can close Geek Parted and save them again. We export our SSD boot. It was dev SDB1, 1 because of our first partition. Now for our second partition we call it cache, and for our third partition we call it system. Oh, if you don't know what I did right now, you can use your arrow keys to go back and forth from your previous commands. Very helpful. Also, when you don't know what you have there, you can use tab. And you have now, this is a directory dev, now you see tab, then 200 possibilities, too much, but let's try SDB. What do we have here? Oh, 3 SDB, our whole mounting point for the actually device, and then SDB1 for our first partition, SDB2 for our second, and SDB3 for our third. Afterwards, we have to update our databases. Oh, that is wrong. apt-get update. And now Elementarios will fetch from the Ubuntu server and their own servers the latest databases to see, well, what packages there are. Now, Elementary OS is based on Ubuntu, the version I forgot, but it's 16.04. Oh, here it is, Senial. So we can access all the Ubuntu software if need be. So now I get our bcache tools. This one manages our caching. It's very important and it's very fine, and it will take all over the dirty work, and we just have to install it and make it ready. After it installs and now has to read the database, update everything, we want to wipe our partitions. Usually when you create a new partition there will be some information on it already, but we can't have that. So we now use wipe fs a all for our previous saved with $, you can access it, SSD, wrong one again, cache. So now you see 4 bytes were already on it, even though we created it momentarily ago. And our HDD point will be also wiped completely. Did I make a mistake here? I don't think so. Oh yeah, here, of course, HDD point. Oh, you see, there's a lot of it. Now everything is finished. Now we need to create our actually bcache. And we say, okay, our cache was at SSD cache. Now you see it's very handy to have previously saved these. And our HDD, not again, point is our backup or our, well, what should be cached. So everything finished, it's set up very nicely. Now we want to change a little bit, this is optional, but we want the cache mode to be write back, and we say with this one, this little piece here, it says write in a file. It will completely overwrite the file or at a specific place, depending on the file. And the cache, oops, that's wrong. We want to go one more bcache, and here we want to change the cache mode to write back. So perfect. Now we export again. Bcache is now our dev bcache 0. Now this dev bcache 0 is a mapping for the whole HDD and the cache partition. It will be automatically put the most used file from the HDD to the SSD cache and so on, but you can exit it over dev bcache. Or we don't want to exit it because now we want to encrypt it. So crypt setup is the way we go. We use a K size. Oh my god, this layout was killing me. Okay, we use this K size and use Luke's format because we want to Luke's encrypt it. Our SSD system. Now we have it. Now we don't have it. Did I forget to store SSD system? Oh yeah, I did. That is too sad. Okay, we need to store, of course, first where our partitions lay. I thought I did that. I did that. Oh, yeah, here, of course, lay size. Oh my god. Case size, of course. Now everything's perfect. So we want our SSD system, which is dev SDB3, to be encrypted with a key with the size of 512. Are you sure? Yes, we are sure, so we have to write uppercase yes. And now we have to enter a passphrase. You can't see it. It is a Linux safety feature to not see the length and stuff, but these are now I entered a passphrase. You should do it too. And as always, an encryption is only as good as the password. If you choose a weak password, it's easily decrypted by anyone. If you choose a strong password, the encryption itself is important for the decryption process. So if the encryption itself is very safe and your password is very long, then it's almost impossible to decrypt for someone who doesn't know the password. Okay, we want also our bcache to be encrypted, so we do that now. And are you sure? Yes, we are again sure, and we use the same password, or I use the same password, because, well, I want automatically decrypt them later together, but that's another case and for another tutorial. So finally, we are ready to open it again. Now we have two encrypted partitions, and we use our crypt setup and say, okay, now we want to open them again. And our SSD cache is the, oh no, not SSD cache, SSD system is our partition, and we call it c-root for, well, crypted root. Now we need to enter the password again. I hope you remembered yours. I hopefully did mine, and yes, everything's fine. Now we do the same for our encrypted cache. It was bcache. And again, password. Perfect. Let's store it. Do not forget it. So our c-root is now mapped, oh god, this layout, at dev mapper, and here's c-root, the name we gave it. And our c-cache is the same but a different name. So every variable is saved. Now we want to create a logical volume manager. And LVM is something very nice. It is a way to use various, well, you create a group of various partitions, and these partitions are, well, these will be created logic, or you will have the opportunity or the possibility to create a logical partition inside these partition group. And it doesn't matter if there are different devices, if these are, well, the size from the actual partition doesn't matter. They will be put together in one volume group, and you can create your partitions and resize them very easily inside. It is really nice. So we create our volume group in c-root. You could also say, okay, c-root and c-cache together as one volume group, and then it will be handled from Linux as if it would be one device, one partition. But that was not very smart, because our c-root should be not the same as our cache. So we have now a physical volume c-root created. And now we create our volume group inside it. Oh, that was a mistake. I said this physical volume is different. Now the volume group you can create more than one. I'm sorry. So we call it this volume group, we call it system, because our system will be there, and it is of course in c-root, our physically volume group. Now system is created. You can see what, oh no, first we create data for our HDD in, you can have guessed, I guess, bcache. Perfect. Now you can see what kind of volume groups you have with wiki display, and you see very nice, we have here 300 gigs in our data, and our system has 96.99 gigs. Very nice. After this, we want to create a swap. The swap is logical volume create, and then our name, we call it swap. The size, big L, is an actual size, small l is a percentage. And we say, okay, it is 4 gigabytes, because on our system, our HDD, we don't want to have a too large cache. It is just a swap. It is just for the possibility our RAM is low. But for the actual hibernation, if you want that, you can create a bigger one at data, which handles if your system wants to sleep and you have 8 gigabytes of RAM, so you need, well, Also 8 GB to hibernate the system. Now, for our system, we want something for root. Let's say 26 gigs, and we have a nice 30 gigs for swap and root. And one for home. For now it's 30 gigs, but later you can easily expand that if your file system supports it. So now for home, now 30 gigs, everything in Linux is stored in your home directory, or most of it. And we might have to increase it later, but it's really easy with LVMs, so don't worry about it. Everything is created. Now let's start the installation process. Install Elementary OS. So let's continue. English, it is fine. Third party, yeah, sure. Download, yeah, sure, it's fine. Well, maybe I have to speed up in a little bit because it will take a while and, well, it's boring for you to watch and I have nothing else to say in that time. So if you find out that I will cut the video in a moment, it is because of that reason. So we choose here now something else that is important. We don't want the standard installation. And we have now a system which looks very nice and very like the part before. And now here's our data swap. This one, of course, we choose swap. And now Linux knows, okay, swap is for swap. Home, it is a XFS. We should use XFS, I heard. It is better than the usually ext4. Our root. If you find a little bit strange movement, I think it's because of my VM. I don't remember that my laptop was also so strange. Our root is our root. Our system swap is again swap. And now only our boot is missing. Where is it? Oh, here it is. SDB1, our boot should be set. It should be an ext2, 3 or 4. We choose ext4, format like everything else, and use boot. If you have an UEFI device, you should make boot twice. One in FAT32 for your UEFI, also boot UEFI mount point, and a normal one for your boot. We will, I don't know if this matters, but we should choose the SSD for our bootloader. So we install it now. Everything looks very nice. And we continue. Yes, I am in Germany. Berlin is fine. The layout, oh yeah, I will change that, not because I fear that also the language is changing. Then, oh well, it's changing because it's really annoying to write in a different layout than you are used to. And you press anything you want here. I press now here. My name is Tix Virtual Machine. My password is the same as before. And I will log in automatically because, well, we encrypt our whole partition. It doesn't matter really if now our home file is encrypted. And now I will speed up this, so don't worry. I will see you when the installation process is finished. So our installation is finished, and now it is very important to not press restart now. If you restart the system now, then you will definitely be stuck in the bootloader because it doesn't know that there are encrypted files or encrypted partitions. You have to first tell the system where your encrypted partitions are, what kind of encryption is used, in our case loops, and install bcache for the caching. So we continue testing. If you accidentally pressed restart now, I will write, or I already have wrote in my blog what to do then. But for now, let's continue testing. Oh, if you wondered why my terminal was closed, during the installation I closed it, not accidentally, but well, did a mistake and started again. And it doesn't matter. We can now open it again, but our variables are lost, which is kind of sad. So we open it again, we change in sudo, and finally I have my keyboard layout I'm used to, so the spelling mistakes should be lower now, I hope at least. And with that, we continue. We mount our newly or freshly installed system. It should be at dev mapper, and here our system called system. And what kind of system are there? Home, root, swap. Oh yeah, we mounted at root, and our mount point is mount. Now we do the same for our boot. You have now here SSD boot, I guess. I don't, so I have to use the real location, which is SDB1, and I mount it at root. Oh, that is wrong. That is completely wrong what I did there. We immediately unmount this root and write boot, of course. Oh god, I made this mistake. I make this mistake way too often, to be honest. Boot, of course. So, that was close. If I would have written, if I would use these as a root folder, then boot would not be there, and everything we do now would have no effect. That would be quite sad. So sys will be mounted and bind at sys, and we do the same for run and for proc with the C, proc, and of course def. Lastly, we change into our new mount folder or now freshly installed system as a root. And you can see here now we are at our root folder from our system as a root user. So to access, we now have to install bcache tools. To access the internet, we first have to give our system a name server. We use the Google name server for it. I think at least it's the Google name server. And write it in our run resolve configuration resolve config file. And to see if everything worked, run resolve configuration resolve config, and we see our name server is 8888. Good. Now let's test it if it worked. Apt-get update. Oh yeah, nicely. You can find the repositories and update the database. And we are finished. Now we can install bcache tools again. It's very small, it's very fast, and it updates also the init trumps. This one is really important. If you don't update the init trumps later also manually, every change we do for our bootloader, it does not know that. We do a lot of change, but we never tell him what we do, so we have to update it. Now we have to write in a file for the bootloader which devices or which partitions are encrypted. We can do that with this command. We say, okay, we have our croot. It is at this way. This is SDB3. But now let's imagine you unplug your SSD or put another HDD inside to have more space, and now suddenly your SSD is as SDC3. Well, then you cannot start your system anymore. So it's better to use the unique identifier. And we use a command. This little character here, it is, at my keyboard layout, is left from return. When I press shift and left from return and then space again, it will come. I don't know where it is at your keyboard layout, but this is important. And then we write block ID, and we need the value from our, here you can write SSD system, but yeah, my variables are gone. SDB3 is our SSD system. And we need the head -1. We need none here and lux. Lux is the format, it's encrypted. We could also specify how much tries we have. I don't do that. So our command is complete. We write it at etc crypt tab. So now let's look at if everything has worked. Crypt tab. Ah, beautiful. You see now, this is the identifier of the partition or the device, if you have the device. In our case, it's the identifier of the partition. And this identifier should not, I think at least, it should not change whatever you do. So if you don't remove the partition, it will not change. So it can be found everywhere, always, and it will unlock then the device and call it croot like we want to, so that everything works fine. We have to do the same now for our cache. It is of course not anymore, you can use again here bcache without a def bcache. I have to use the real path without a variable. It is at bcache 0. And of course it's not croot anymore, it is ccache. Also important, if I now press enter, it will be overwritten. We have to shift it to the last line. Now it will get the file and go to the last line and then put our command inside. And it is nicely. Good. We have both unique identifiers now saved. And we have to update what I told you before, the bootloader. Here, update init trams UK all. Now it updates the bootloader, and our bootloader now finds our encrypted devices and can, with our password, decrypt it at startup. We exit it, we sync it, and we unmount it. Unmount, let's start with boot, and let's go with sys dev run proc, and of course the whole mount partition. Now we have to turn off our swap or swap. It was turned on by Linux automatically when after the installation when it was created, but now we want to unplug everything and sync everything, so we need to do it manually. Our now we want to change, also simply change and deactivate our partitions. So we say dev mapper system, very nice, and data zero logic volumes in volume group data now active. That is what we want. And finally we close both. Now we can safely close it because everything is written there. We close croot and we close ccache and we sync everything. Now we are finished. Let's hope everything works well. We will boot now and we have a new Linux system. So that's it. If anything was unclear or you have more questions, please leave a comment. If you have feedback, please also do. This was my first video and I hope it was informative. You can also check out my blog, the link is in the description, to maybe read more or also leave a comment and also to find it more clearly written and not just explained. Goodbye.